Today's lesson is about solving two-step equations. We will be following these steps. Our first big idea is whatever is done to one side of an equation must be done to the other side. Otherwise, both sides won't be equal anymore. Our other big idea is more than one inverse operation is needed to isolate the variable in a multi-step equation. Work backwards to undo the operations. And let's start with our first example. Let's copy down the original equation. We will start the inverse operations with constant first. In this equation, -5 is our constant, so we'll do the inverse operation. Since it's -5, we're going to add 5 to both sides of the equation. The equal sign determines the sides of the equation in equations, just keep in mind. So bring down whatever left for you. Since -5 plus 5 is 0, I don't need to write it down, but I have equal sign here. And 16 plus 5 is 21. So we did the inverse operation part and then original equation. And this was the simplifying step. Now we have to do another inverse operation. This time we will do the inverse operation on coefficient. Since 3 and x is being multiplied, 3 is our coefficient, and 3 is being multiplied, the inverse of it will be divided. So we're going to divide both sides by 3, and then from here, our solution will be 7. Let's see if it is the right solution. The last step is check. We are going to go and substitute 7 for x in the original equation and see if we have the both sides of the equation 16. Let's use another color to show substitution. -5. So we're checking if it is equal. So 3 times 7 is 21. -5 is it 16. So this part of the equation will be 16. Then yes, so we got this right. Well done. Let's continue with another example. Let's copy the original question. X over 3 plus 9 is 15. Then let's start doing the inverse operation on constant. So subtract 9 from both sides. Remember, the equal sign determines the side of the equations. And then bring down anything left on left side, which is x over 3. Bring down the equal sign. And then 15 minus 9 will be 6. And then next step is now our coefficient is 1 over 3, or we can also think as x is being divided by 3. So the inverse operation would be multiplying both sides of the equation by 3. So let's multiply both sides of the equation by 3. From here, x will be 18. So as I said before, we are going to check if x is 18 by plugging in or substituting 18 again in the original equation. So let's just title here check, and let's use another color. So 18 over 3 plus 9 is it 15. So that's what we're checking. 18 divided by 3 is 6. 6 plus 9 is 15. So we also good to go here. Well done. Okay, next question. We have decimals, but our strategy is the same. We're going to start with constant. We're going to do inverse operation based on constant, but also please notice that your x is on the right side this time. Your variable is on the right side. It is okay. So variable can be on either side of the equation. We will do the same steps. So let's go ahead and start with writing the original equation, which is 9.3 is 0.6x plus 3. Our constant is 3 here. We're going to start doing inverse operation on constant by adding or subtracting whatever it required for us to do. So subtract 3. Be careful because here you're applying decimal subtraction, so you need to line up the numbers. Let's put a placeholder for tens place value for 3, and you have here 6.3, and then bring down 0.6x, and then because positive 3 minus 3, when you add them you will get 0. We don't need to write it down. Okay, let's continue. Next inverse operation would be dividing both sides of the equation with 0.6, since 0.6 originally multiplied by x, and then these will be canceling each other because 0.6 over 0.6 means 0.6 is divided by 0.6. So when you divide 6.3 and by 0.6, your final answer here will be 10.5x. So you can write either this way, but it is actually more probably desired to write x on the left side and then solution is on the right side. So it is 10.5. Okay, let's check our work. 9.3 and then 0.6. We're going to go ahead and substitute 10.5 for x, and plus 3. So let's rewrite 9.3 is it equal to, so 0.6 times 10.5 will give us, let's see, 0.6 times 10.5 is 6.3, and plus 3. When you add 6.3 and 3, you will get 9.3. So the left side of the equation is the same as the right side of the equation. Then we got this right again. Good to go. Great job. Here's our next question. Example 4 has fractions, but the strategy is the same. Let's go ahead and start with copying our original equation. Negative 5 over 8x plus 1 over 3 is equal to 10 over 15. And our constant is 1 over 3, so we're going to do the inverse operation. 1 over 3, 1 over 3, so we subtract 1 over 3 from both sides. And then we have negative 5 over 8x is equal to 10 over 15 minus 1 over 3. So two things we can do here. We can simplify 10 over 15, or we can create equivalent fraction by making the denominator same. So I'm just going to actually simplify this. It's much more easier and faster. 10 divided by 5 is 2, and then 15 divided by 5 is 3. So the equivalent fraction of 10 over 15 would be 2 over 3 by simplifying. So let's go ahead and replace 10 over 15 with 2 over 3. Then what we have negative 5 over 8x is equal to 1 over 3. To isolate x, let's multiply both sides of the equation with reciprocal of the coefficient, which will be negative 8 over 5. And let's multiply also other side with negative 8 over 5. And cross cancelled here, negative times negative is positive. So from here, what we have, x is equal to negative 8 over 15. go ahead and check. Negative 5 over 8 times negative 8 over 15 plus 1 over 3, is it the same as 10 over 15? So when we do cross multiplication here, negative times negative is positive, and then I can also do cross canceling. This will be 3. So what I have here on the left side of the equation, 1 over 3 plus 1 over 3, because these are all 1. And 1 over 3 plus 1 over 3 will give us 2 over 3, which is the same thing as 10 over 15. How we know, we simplified 10 over 15 and replaced it with 2/3 when we were solving the equation. Let's do it again. 10 divided by 5 is 2. 15 divided by 5 is 3. As you can see, 2 over 3 is equal to 2 over 3. And then we can say, yes, we got also this one right. Okay. Now question number 5. We have decimal and mixed number together in this equation. But again, the strategy is the same. But what I recommend here, that either you write everything in decimals or fractions. It is easier to do the operations. I'm going to actually write 0.3 as 3/10. Okay, let's write the original equation, but I converted 0.3 to 3 over 10 minus, and then also I would like to change this mixed number to a common fraction, which will be 1 and 1/3, as we multiply 1 and 3, and then we add, here we multiply, and then we add 1. So then this one is equal to 4 over 3. And I would like to write that one here as 4 over 3 instead of 1 and 1/3. And then finally, I can now start doing the inverse operations. Our constant is 4 over 3, and then the sign of constant is negative. So we're going to do inverse operation by adding 4 over 3 to both sides of the equations. And then this will be cancelled. We have 3 over 10q is equal to 2 plus 4 over 3. I'm going to do on the side this fraction addition, 2 plus 4 over 3. Let's put 1 under, and then we have to have common denominators. To have common denominators, I'm going to multiply this by 3, but I have to do the same thing for a numerator, right? So from here, 2 times 3 will give us 6 over 3 plus 4 over 3. When you add, this will be 10 over 3. Then let's go ahead and continue with equation solution. So q is 10 over 3. We're almost there. Now we have to isolate q by multiplying both sides of the equation with the reciprocal of the coefficient. So let's go ahead and multiply both sides of the equation with 10 over 3. And cross cancel. And we have only 1 left on the other side as a coefficient of q. Then on the right side, we have multiply numerator by numerator, and then denominator by denominator. Then q should be 100 over 9. So this is our final step. I'm going to have you pause the video and then do the checking part, and then let's move on to the next question. Okay, let's move on. Last question, negative 0.6 plus m over 0.5 is equal to 1.64. Let's go ahead and start with taking care of constant first, but of course write the original equation. So negative 0.6 plus m over 0.5 is 1.64, and let's add 0.6 to both sides of the equation. So please don't forget to line them up. Remember, when you are adding decimals, you need to line them up. So these are canceled, and we have left on the left side of the equation m over 0.5. On the right side, we have, if you add, it is going to be 2. We will have 2, 4. Okay, and then the next step is we are going to multiply both sides of the equation with 0.5 to isolate m. And multiplying with 0.5 is the same thing as dividing by 2. So we're pretty much taking the half of 2.24. Okay, well done. Now, I would like to have you again try and see if we have the right solution by plugging in or substituting 1.12 for m in the original equation. Go ahead and check it. Okay, we should be good to go. We're done. Have a wonderful day, guys.